chairing this session. I welcome you, ladies and gentlemen, to this session, weaving session. It seems to be very, very innovative and important session. There were supposed to be 5 speakers, but now one of the speakers has dropped out and has not come due to some visa problems from Iran. So there will be 4 speakers. So I hope that we will be able to devote a little more time for questions and answers. So first paper is an innovative technique for the design and production of multi-axial color arrangement structure, short MACS. This is woven textile and it will be delivered by Dr. Tarek El-Shafeey. Dr. Tarek is a member of Engineering Committee, Consultation of Apparel and Textile of Design and Technology. Please, ladies and gentlemen, welcome Dr. Shafeey.
بسم الله الرحمن الرحيم ولا يكون شيء من يديه الا ما شاء وسع كرسي السماوات والارض ولا يؤوده حفظهما وهو العلي العظيم. Another class and innovative technique for the design and production of multi-axial color arrangement structure max woven textile. But consultant Dr. Engineer Tarek M, lecturer Textiles, Faculty of Special Education, University of Tanta, Egypt. Introduction, sale, materials and methods, results and discussion, conclusions and recommendation. Introduction. Yarn material is one of the most important factors to increase the artistic values. So, this study succeeded to obtain new technique for designing new woven textile products built on incorporation of multiplicity of yarn, ends and wefts, multiplicity of interlacing point along the length or the width of the adjacent parts of the design, with multiplicity of yarns, color arrangement, yarn counts, yarn setting, weaving structures. Serious history of the trends has been reported. Theory of the weave of products using the new technique, multi-axial color arrangement structures or MAX, has been described on a geometrical plan depending on the interlacing patterns on the surface in adjacent parts of the artistic design. Analysis of structures of maps have been designed, have been scanned. Also, many studies have been carried out to produce unique woven products using maps technique. So, after many trials using cardboard, finally wooden frame was used to weave fabric by using max technique. This figure explains the idea of execution when design using the new technique as shown. This figure S1, the rectangle S1 represents the wooden frame, and the rectangle S2 represents the woven area, which intersected into 9 parts: A, B, C, D, E, F, G, H, I. Every one of these parts was woven alone with specific specifications. Every line named TT. Every line which named TT represents work directions. And every line named FF represent weft directions.
Excuse me, please. Can you use the mouse to, because it's not clear to see the or pointer. Yes, yes.
نعم؟ هو مش سؤال. هو عايز بس اشاور every part if we see here in this area this line F3 F4 represent weft direction and T3 T2 this T3 T4 this line represents warp direction. When this line be dotted line, this means that no interlacing between weft and warps. So the yarns will be floating under the woven area. The idea of production moving area by using max technique. This figure represents the theory of weaving a circular area of design by using max technique. This square represents the wooden frame, and these lines AC, BD, EG, these lines represents warp direction, and these lines represent weft direction. These lines, A dash, F dash, these represent weft direction and make interlacing with this line to make the woven area. When this line be dotted as F dash K or A dash K dash, this means that there are no any interlacing between wefts and warps. Materials and methods. To produce specimens using the max technique, wooden frames were employed in dimensions as follows. Acrylic pulpy yarns of 400 tenure used in marks and wefts of all samples, in addition to satin tapes 5 mm, which partner acrylic yarns in some parts of the design in samples 4 and 5. Several samples were woven by using max technique. Details of 5 samples were chosen as an experimental works in this paper. Also, photos of some earth samples etc. Symbology of colors and weaving structures and adjacent parts of artistic design experimental works. This table represents here the color, and here the sample of the color, white, W, gray, GR, etc. And the weaving structures, symbol, plain weave, B, etc. These two the specifications of weaving sample 2 as an example to according to artistic design in the following figure. This table represents the specifications of one sample. All samples was as this table. This is the part according to this artistic design, and this is the figure of every part of the artistic design. This is the number, and this one arrangement in the beat. Numbers 6, 6, 6, 3, 4. 6 of R, 6 of PR, 6 of NY. This is the colors, and this is the number of the weft in the beat. 4, 4, 6, 6. 4 of yellow. 4 of brown. 4 of navy yellow. Excellent. And this is the weaving structure. This is the artistic design of the sample, previous sample. And this is the design executed by using the previous technique. This every part of the design here has a specific arrangement of warps or wefts, and has a special weaving structure, and has a special direction. The direction here between wefts and warps. Warps here this direction, and wefts this direction. But here the direction of warps here and wefts here. The direction here between warps and wefts. Samples to moving scrap while using max technique. This is the magnification of area A of the scrap in sample 2. Results and discussions. Multi-axial arrangement of colored yarns in warps and weft structures executed in every part of the artistic design. We designed and produced multi-axis arrangements of colored yarns in warps and weft structures executed in every part of the artistic design. Were designed and this is artistic design of one sample 1, and this is the moving scrap by using max technique. This A will be magnification. This is a magnification artistic design of sample 3. Photo of sample 3 moving scrap by using maximum technique. Here also there will be two direction of warps and wefts, and the direction is different in every part of the design between warps and wefts. This is a magnification of area A of graph in the previous design. Artistic design of sample 4. This A will be magnification now in this photo. Magnification of area A of table closed in the previous view. This artistic design of sample 5. Amplification of area A of bit spread in the previous design. This here every weft or warp has a special direction. Photo part of moving bit spread reduced by max E. You see here various curves. Every one of it will move in two directions of warps and width, the different from the others. Photo of moving bit spread reduced by max E. Here, these lines seem to be in a curve, but every one of this part has a direction of warps here, or here, or here, or here, etc. Photo of moving bit spread reduced by max E. Conclusions. From the following discussions, it follows that it became possible to weave textile products by using the new technique. Useful information are provided towards the method of producing a new structure with multi-axial colors arrangement in both of warps and widths, weaving structure. This new technique of textile structures called MAX. Many designs reduce this structure or many folds, such as straps, tablecloths, width spread, etc. According to the experimental results, we gained a new technique, textile product with a design including multiple factors which added aesthetic values to the surface of the woven adjacent parts by the incorporation of these factors each other. Up till now, using MAX techniques to produce woven products still by manual device. So, this study recommends to mechanize it to manufacture its design products in mass production and short time. Also, the layers of floating adjacent yarns in axial directions added some characteristic traits to the product, claim to test the mechanical and physical properties of MAX products. With regards to organizers and partners. Thank you.
Ladies and gentlemen, I think we have time for one or two questions. It's a very, very interesting technique. If anybody would like to ask any questions, please. Thank you. Can we put the light on, please? So, where?
I have to move here.
No. Carry on.
First, I would like to ask about what the meaning of MACS.
MACS
Yes.
means multi-axial color arrangement and weaving structure.
Second question, is the kind of tapestry it's making by hand or
By hand.
mechanical?
By hand.
mechanical. So what about the sizes for bedspread and the scarf or tablecloths? So you have to make a big frame for
Yes, yes, and the specification in the work and in the works.
And you mentioned as a manual device. What do you mean by manual device?
Manual message.
Hands.
Hands, yes. Okay.
Thank you.
Thank you.
Yes, Dr. El-Shafeey, I wanted to congratulate you for the good piece of work. Yeah. I mean, your thoughts went in a different direction. In fact, one of the graduate students at Georgia Tech, my name is Krishna and I'm from Georgia Tech. One of our students recently wrote a concept paper on multi-axial interlaced fabric production, and we have not demonstrated fabric production using the concept so far, and I'm very glad to see that you have actually shown fabrics with interlaced threads using this principle. And we are still working on the system. We are not completely developed, even in the concept paper, we are not completely defined the system. But I am inspired by what you have shown here. And thank you for that.
Thank you, Dr. Shafeey. Thank you very much. Let's give him a hand.